Okay, fine. So very good evening, guys. So this is the first lecture for our 2025 GATE aerospace preparation. So I'll be starting with aircraft structures as we have already discussed in the demo videos. Monday and Tuesday we will be doing aircraft structures in starting. So we will start with strength of materials. Then Wednesday we will go with the maths lecture, which is always fixed for your entire year. And then time being Thursday and Friday, we will start with fluid mechanics, and then we'll slowly move towards aerodynamics portion. All right. So this is the initial days. Now, before going into the actual equations and solving numericals and understanding topics and structures, I want you people to understand what your structure syllabus is and what we're going to learn throughout this whole structure syllabus. All right. So I hope my slide is visible. I'm going to the next slide now. So if you see, I have kept few things here for few animations so that you people can actually relate. The only reason of keeping these animations because structure is considered to be the most difficult topic in aerospace domain. The reason being, you cannot visualize structural things. You cannot visualize stresses. You cannot visualize strains, energies. All these things are difficult to imagine in our mind, and hence it is difficult to solve numericals and understand concepts. When we go to flight mechanics, you can actually see aircraft taking off, landing, turning. You can see all those things. Similarly, you can see in aircraft propulsion how compressor is rotating, how your engine is producing thrust and moving forward. So all these things are possible, correct? So I just briefly explain what your whole syllabus is, then we'll enter into the major syllabus or major equations. So first thing which you see in slide is I have written tension and compression. Now before doing that, I just want you people to understand or imagine in your mind, let's say you have a stick or let's say you have a pen in your hand. All right. And the only task I gave you is to break this pen into two halves. Like you just want to break this. Guys, do you people see my second slide? Let me share the slideshow if possible. Just give me 1 second. Now you please tell me if you can see my slide share. You can see the second slide. Now you can see, right? Perfect, perfect. Okay, fine. So coming to this, now if you see, you have tension and compression mentioned here. As I told you, I'll start with a simple example in structures. So imagine you have a pen in your hand and I gave you one task that you need to break this pen, all right, or a stick or anything, maybe a mobile phone. So what all possible things you can do to break this pen which is in your hand? The first thing what you can try is you can pull this pen. If you see in the image on the left hand side, you can take this, imagine this is your pen and you're simply pulling it in this direction. All right, this is one thing what you can give it a try to break this pen. This is known as tension. All right, you're applying an axial force, you're trying to pull the system. That's the first thing came to our mind. So this is referred to as tension. I'm not going in detail in any of these equations now. I just want to tell you what your syllabus is. Then the another thing what you can do is you can take the same pen or a stick or a rod, whatever you are dealing with, and then you can apply a full compressive load to it. Correct? You can do that as well. But you can imagine, even if you give this to a child, right, that child will not going to break the pen by applying a tensile force or by compressing it. Don't do that. Never. You will also not do that. So you have two kind of things which is possible in structures: tension and compression. We will see why these are known as axial loads and what kind of stresses are generated. That is altogether separate thing. But another thing what you can also give it a try is by bending the pen. So what you can do is you can hold pen from one end and try to bend in the other direction, something like this if you observe. Or You can just simply hold your pen with your left hand and right hand and just simply try to bend it. That's what we typically do, right? If you want to break any stick, the first thing what you'll do is you always try to do bending. All right. So you can compress a system, you can elongate a system, you can bend a system, which is known as bending. Now you will have different configurations, different bending names. All these things are separate. Then you can even provide a torque to a system. What you can do, you can hold your pen, if you can see in this image, and you will try to twist it. This is another kind of loading in structures. So you can twist the system. So you can bend, you can twist, you can pull it, you can compress it, and all these will give you different kind of load conditions. Different kind of load conditions means your pen or the structure will experience different kind of motions or different kind of deformations. If you see in this image on the right hand side, this beam is trying to bend like, or try to twist like this. In the previous slide, if you see, this beam is trying to bend like this under the load. This beam is bending like this up and down. That's what it is trying to do here. If you see, it is bending like up and down. Similarly, in first slide, it will try to elongate, it will try to compress. So all these things you people can do if I'll give you a structure. Now, this structure can be a pen, it can be a complete aircraft also, right? So when you have your aircraft, let's say a complete aircraft, you're talking about wing or fuselage or tail, it can be subjected to tensile load, it can be subjected to compressive load, it can be subjected to bending, it can be subjected to torsion. So, as an aircraft engineer, as a structural engineer, your motive is what kind of loads are acting, what it will do to my structure, how the shape of my structure will going to change, and will it going to fail or not. That's the major answer, right? Your aircraft wing should not break. It should do its purpose. It should help our aircraft to fly. So in the end, we need to decide whether our aircraft will going to fail or whether it will going to pass. That call we need to take, right? So another kind of, not the loading, another kind of structure which you must have heard about it before is known as columns. All right. This is also one syllabus important point in your aerospace syllabus. If you see in this case, the structure will not going to fail. The structure is not going to break into two pieces. The failure is known as buckling in this case. Now, what happens if it is a long column, right? If you see there is a huge length here, and to this, if you apply compressive loads at both the ends, now again, there are different boundary conditions. I'm not going into that as of now. Under these conditions, you can expect that this structure will going to buckle like this. It becomes like a bow, correct? So this is also one kind of failure. You don't want this. You don't want your structure to have a bad shape. It should be firm. It should be stiff. So another topic or another loading conditions on another kind of structure which we will see are nothing but columns. All right. Then you have trusses also in aircraft applications. So trusses you must have seen in bridges, correct? You have seen the overhang bridges, you have seen the railway bridges, and you have seen all these kind of structure. If you see, this is nothing but your truss frame, which you can see here. And then if you apply certain amount of load, maybe people are traveling over it or car is going over it, you have these frames in your aircraft wings as well in the aircraft applications. So it is part of our syllabus. So whether it will going to take the load, whether it will going to fail, whether it will going to break, all these questions we need to understand. So trusses is also one kind of problem which is coming in the exam. And this is the whole, I can say, syllabus of your aircraft structures. So what you need to understand, what will happen when you apply a tensile force, what will happen when you apply a compressive force, what will happen when you try to bend a system, what will happen when you try to twist the system, what are columns, how they fail, where they are used, what are trusses, where they are used, how you're going to solve or predict whether this truss is good or bad. All these things we need to understand. Now, in structures, when we say structure is good or bad, the best thing to analyze it is by calculating stresses. Now, all right, so I'll go to stresses. The whole lecture today is on basic elasticity. As of now, I'm just telling you what basic elasticity wants or what basic elasticity will do. So you apply certain amount of load. Now, when I use the word load, you should fix in your mind it can be anything. It can be tension, compression, it can be bending, it can be torsion, or it can be combination of all. So you can have a system which is bending, twisting, which is having tension loads, which is having compressive loads all together. This is what happens in real life. And under that, whether my system will going to pass or my system will going to fail is our job as an aerospace engineer in structural domain. All right. Now, to take this call, there are few theories developed. I have kept this image. The only reason is, guys, if you see on the right hand side, right, this exactly same question was asked in 2024 for 2 marks. The question was this circular diagram and this rhombus kind of image. If you see, which one represents what, which one is one misses, which one is Triska, that's what we need to mark in the options. It was multiple select question, and there are typically total 5 theories in it. I have just given an example. Now don't worry about what these theories are and sir directly from where these theories are coming. The intention is you calculate these stresses, and then these different theories will tell you whether the system will going to fail or it will going to pass. Very simple example. You are working in, let's say, Airbus, and you're trying to predict whether your aircraft wing will going to sustain these loads. Now what you'll do is you'll go towards one Mrs. theory of failures, and there are certain rules which you need to follow. You need to calculate certain amount of stresses, you need to calculate certain amount of expressions, and then one Mrs. theory will tell you whether your aircraft is passing or your aircraft is failing. That's what your whole job is. One Mrs. is the most used equation or the theory in aircraft domain. The next is Triska, and similarly we have Rankine, and we have multiple theory of failures. All right, so this tells you whether it is passing or failing. So you should know what kind of loads are acting, and then you will predict the stresses, and then you check these stresses whether they are good or bad depending upon these diagrams. This is your whole aircraft structure syllabus. All right, so the topics are basic elasticity, which tells you how to calculate stresses, tension, compression, all these things. Then your next topic is bending. Then your next topic is torsion. Then your next topic is columns, trusses, theory of failures. This is your whole, I can say, bucket of your aircraft syllabus. And then the last topic, which is not part of this domain, is what is known as vibrations. All right, so you need to understand vibration in detail. It is a dynamic phenomena. I'm not trying to confuse you with all these heavy words. But here, what you'll do is you will see what is happening to my system with respect to time. All right, so if you see this black mass, which is attached to a spring, right? And it is just going up and down. This is vibration of a system. All right. And if you see on this right hand side, you can see this black system is moving like this. This is just plotting what is happening to this black system. Now, if you see this blue, this is vibrating, but it is dying out with respect to time. Correct? So if you see, it is starting like this and then it is dying out with respect to time. Means vibrations are dying out with respect to time. So I hope you understand what is the meaning of vibration. When system oscillates about the mean position, that is what is known as vibration. And below also I have given one example. So this is one mass, this is another mass, and both these masses are closing, opening, closing, opening. This is also another kind of vibration phenomena. We will see this is 2 degree of freedom system. So I hope you understand your syllabus. You know what your whole aircraft syllabus looks like and how we're going to solve, or what numericals you need to solve in this. All right. Now what I'll do is I'll go into my presentation into my PowerPoint mode, so that I can write things and we'll start developing certain amount of equations which are needed, or what all things we need to study in basic elasticity. All right. I am again repeating this. This is not developing any basic. Guys, your gate numericals start from the first lecture. So whatever we're going to do today is the backbone of your whole aircraft structures, whatever you will be doing throughout the whole syllabus. All right. Let me just quickly share again. I'll just share my iPad now, so that I can just quickly show you the whole syllabus, and then we will start with the equations. All right, just give me 1 second. All right, I hope it is visible. You people can see the screen again. Perfect. Now, I want to tell you this. So when we talk about your whole aircraft syllabus, right, what we're going to understand is our first topic, which is known as basic elasticity. So you will be talking about tension and compression in the system. And this we will cover under basic elasticity. It will have multiple things: plane stress, plane strain, which I will discuss in coming slides in 1 or 2 minutes. Then your next topic is bending. You can imagine what bending is. Bending is this thing bending like this, all right, or this whole system bending like this. This is what referred to as bending. This is our unit 2. Unit 3 is torsion. You can expect how the system will going to bend, or how this system will going to twist. That is what is referred to as twisting. All right. Unit 3. Unit 4 is columns, in which you will apply the compressive load to the system, and your system will try to buckle. This was the mean position and it buckles. This is also one unit we need to study. Then we need to study trusses, which is altogether a very simple topic, but still I've kept it separately because they are asking this in your exams continuously. Then combining all this, you have theory of failures, in which you will be studying 5 theories completely. And then in the end, we will do vibrations, which is altogether a separate topic from all the topics we have discussed before. Because in vibration, we will not calculate any stresses and all. We will see how our system is vibrating, how our system will going to behave, if how a pendulum will going to vibrate, how a trolley system will going to vibrate. You must have seen all these kind of examples during your BTech curriculum. I don't expect you to know this, but something like this, how system will going to vibrate or what system will going to do, is what we're going to understand here. All right. Now, okay, so let's start with our first unit, guys. So this is your first unit. All right. And as I told you, this unit is the backbone of your entire structures. So you have to study this unit very properly. We will solve each and every gate numerical. We will solve many example problems. We will do it together, but you have to understand the concept. There is no way you can learn this. You have to understand this. And when I say weightage white rice, this is somewhere around 3 to 4. It can even go to 5 marks in some of the question papers, but you can say 3 to 4 is approximately what this basic elasticity will going to cover. Now, if you see the list, right, I'm not going to go each topic now because it doesn't make sense using these heavy words like compatibility conditions and thin walled pressure vessels. But this is for your reference that once this topic is finished, you will be covering each of these topics, and we will going to mark it here that whether we have solved it or not. All right. And each topic, whichever thing is mentioned here, is asked in your exam already many times, and we will try to slowly develop our theory concepts related to each topic. Now, first thing, I want to start with basics because I don't want you to know strength of material before starting aircraft structures. So if you see, you're seeing the words stresses here, right? You will see this very often: stress strain relations, strain displacement relations, airy stress function, plane stress condition, thermal stresses. So stress is a word which we need to look into detail. So now let's start our main equations, how what we are trying to establish here. If you see in the next slide, although it was the animations, but it's fine. I'm not going to switch back to show you the animations. It's perfectly fine. Yep. Guys, can you just give me a quick nod? Is it clear for everyone up till now? Are we good? Two people can see my screen, right?